case 4 of integration. Okay. So in AS, we learned how to integrate y equals x power n. So that was equals to x n plus 1 upon n plus 1. And if it were instead fx power n, then the integration was fx n plus 1 upon n plus 1 times the derivative of x. In all these cases, the fx was linear. That's why we were directly integrating like this. We were using the shortcut actually, not the actual longer method. Uski thodi examples karte hain, and then we discuss the case where fx is not linear. Okay, so first let's discuss the case where fx is linear. Okay, so that would be integrate 2x minus 7 power 12. So then using this rule, it's going to be 2x minus 7 power 13 upon 13 times the derivative of fx, which is going to be 2. So that's going to be 26 in the denominator. And a plus c here. Integrate 6 minus x power 12. Power rule again. 6 minus x power 13 upon 13 times the derivative of 6 minus x, which is minus 1. So we get minus 6 minus x power 13 upon 13. Okay. Now, what happens when fx is not linear? It's integration of fx power n dx, but now fx is not linear. When that happens, then it's must that you must be given the f prime x, the derivative of fx multiplied to fx power n. Ye hoga, to only then we can move forward. And how do we move forward? The result of the integration is simply going to be fx power n plus 1 upon n plus 1. That's it. Plus c. Okay. So let's look at an example. There's integration of 3 sine square x cos x dx. In fact, there isn't a 3 with it. Integration of sine square x cos x. Okay. So we do have a function with the power on it. The power is 2. The function is fx. Do we have the derivative of fx with us? The derivative of sine x is cos x. So we do have the derivative. So this rule is applicable. We have fx power n, and with that we also have f prime x. So then the result of the integration is fx n plus 1 upon n plus 1. That's it. Plus c. So then the result of integration will be sine cube x upon 3 plus c. कोई questions है तो पूछो please. Integration of square root of 1 minus x square, which is definitely not linear. So that means you would be given some sort of the f prime x. So you're getting given x with it. Okay. Now, what's the derivative of 1 minus x square? It's actually minus 2x. So we just have x. But that's not going to be a problem because we can multiply and divide a constant on either side of the integral. So I'll write minus 2 here and 1 upon minus 2 here, or minus half outside. I've not changed the question at all. I've just multiplied with minus 2 inside and then divided with minus 2 outside. So now we have a function fx with power half, and with that we also have its derivative dx. And then the result is fx n plus 1, so half plus 1 upon half plus 1 plus c. So there's also a half outside. So a half outside minus half outside, in fact. So minus half, and the result of integration is 1 minus x square. Power is half plus 1, which is 3 upon 2. And in the denominator, we also have 3 upon 2. And then plus c outside. So we get minus 1 by 3, 1 minus x square, 3 upon 2 plus c. Another one. Integrate 1 upon 3x plus 2 power 2 dx. That's the linear function. Let's send it to the numerator. So we get integration of 3x plus 2 minus 2 dx. Since it's linear, we're going to use fx n plus 1 upon n plus 1 times derivative of fx. So that's going to be 3x plus 2 minus 2 plus 1 upon minus 2 plus 1. And then the derivative of 3x plus 2 is 3. So we get 3x plus 2 power minus 1 upon, in the denominator we have minus 3. So we may rewrite it as minus 1/3, and in the denominator you can write 3x plus 2. And plus c, of course. Do not forget the plus c. Another one. Okay. So that's not a linear function with the power 5 on it. So that means now we have to use fx power n, but with that you must also be given an f prime x. Only then you will be able to integrate it to fx n plus 1 upon n plus 1 plus c. So do we have the integration of this with us? Yes, we do. The integration of 3x square minus 5x plus 1 is going to be 6x minus 5, which is right here. So then we apply the power rule. It's going to be 3x square minus 5x plus 1 power 6 upon 6 plus 6. Next would be integrate cos power 5x. Since that's definitely not a linear function, you would be given f prime x with it to some extent. So we're given times sine x with it. So cos power 5x sine x dx. So again, we have a non-linear function with the power 5. We cannot apply the power rule of integration unless we have f prime x being multiplied with it. So what is the derivative of cos x? The derivative of cos x is minus sine x. So we should have minus sine x here, but that can be fixed by writing negative here and multiplying that with negative 1. So now we have minus cos 6x upon 6 plus c. Next up is sine 4 2x times cos 2x dx. So do we have the derivative of cos sine 2x with us? We do. And not exactly. What's the derivative of sine 2x? It's going to be cos 2x times 2. So there's a 2 missing. So what we can do is multiply 2 here and multiply half outside. So we get half. And now we apply the power rule, sine 5 power 2x upon 5. So we get sine 5 power 2x upon 10 plus c. next would be integrate secant square x tan x dx. We do have a function with the power on it. Do we have the derivative of it with us? Secant square x का derivative क्या होता है? Secant square x का derivative तो हमने पढ़ा ही नहीं हुआ. हमने derivatives जो पढ़े हुए हैं ना वो ये पढ़े हुए हैं. Derivative of sin x, which is cos x. Derivative of cos x, which is minus sin x. और फिर हमने पढ़ा हुआ derivative of tan x, which is secant square x. So secant square का तो हमने derivative पढ़ा नहीं है. Secant square की हमने integration पढ़ी है कि when you integrate secant square x, you get tan x. So no, we do not have the derivative of secant square x here. However, अगर इस क्वेश्चन को रीअरेंज किया जाए, tan x को पहले लिख लिया जाए और secant square x को बाद में लिख लिया जाए. Integration of tan x secant square x dx. अब क्या हमारे पास tan x का डेरिवेटिव गिवन है? वो गिवन है. So tan x का डेरिवेटिव होता है secant square x. So we have a function fx whose power is 1, and with that the derivative of fx is also being multiplied. So now we will use fx square upon 2 plus c. Fx power 2 upon 2 plus c. So it's going to be tan x, tan square x upon 2 plus c. कोई क्वेश्चंस हैं तो प्लीज साथ साथ पूछ लो. Okay, another one. Integration of secant square x 10 power 5x dx. Same rule use होगा. fx power n पे power rule खाली तब लगता है जब उसका डेरिवेटिव के साथ मल्टीप्लाई हो रहा हो, अगर ये नॉन लीनियर है. It's going to be fx n plus 1 upon n plus 1 plus c. So we're going to write tan power 5x first, क्योंकि tan का डेरिवेटिव होता है secant square x. So it's going to be tan power 6x upon 6 plus c. Okay, next step. Integrate 3x square minus 6x plus 5 whole power 8 times x minus 1 dx. Do we have the derivative of 3x square minus 6x plus 1? Sorry, plus 5. Its derivative होगा 6x minus 6. So we just have x minus 5. But that can be fixed by multiplying a 6 inside and dividing a 6 outside. So then we get 1/6 function would be 3x square minus 6x plus 5 power 9 upon 9. So we get power 9 upon 54. And plus C. Then it's integrate ln x square whole power 5 times 1 upon x dx. Okay. So first let's see what's the derivative of ln x square. Before that, let's apply the rule of log. If it's ln x square, can be written as 2 ln x. So we're derivating 2 ln x. So that would give us 2 upon x, because the derivative of ln x is 1 upon x. So we don't have 2 upon x with us, but we can multiply 2 here and divide 2 here. So now we have half ln x square power 6 upon 6 plus c. So that's going to be ln x square power 6 upon 12 plus c. Okay. We're done with case number 4. Case number 5 कल start करेंगे, लेकिन उसके लिए हमें partial fraction चाहिए होंगे. थोड़ी सी partial fraction की revision कर लेते हैं, so that tomorrow we can directly start the case. Okay. यही partial fractions हम कल use करेंगे, so tomorrow we'll just use the result. Today we'll actually do the partial fractions. Partial fraction का chapter हम कर चुके हैं ना, मैंने कराया हुआ तुमने, right? I will take that as a yes. कराया हुआ है. एक P3 में 1-2 महीने पहले ही कराया होगा, probably 2-ish months back. Okay. So the question is, इसकी partial fraction करनी है 8x plus 1 upon x square plus x minus 2. पहले डिनोमिनेटर को फैक्टराइज करना है. So x square plus x minus 2 को हम की मिडिल टर्म ब्रेकिंग कर लेते हैं. So we'll have x square plus x minus 2. It's going to be x square plus 2x minus x minus 2. X common, x plus 2 minus 1 common, x plus 2. So we have x plus 2, x minus 1. So that gives us this in the denominator and 8x plus 1 in the numerator. अब इसकी partial fraction कैसे होती थी? A upon x plus 2 plus b upon x minus 1. अब हम इधर एलसीएम लेंगे और डिनोमिनेटर को खत्म कर देंगे. So the denominators cancel out. And we have 8x plus 1 equals a x minus 1 plus b x plus 2. So 1 ले लेते हैं. So we're getting 9 equals 3b. क्योंकि ये तो 0 हो जाएगा. एक ही टर्म एलिमिनेट हो गई, so b equals 3. Now I'm going to substitute x is equals to minus 2. We get minus 15 equals a times minus 3. So minus 3a और b की टर्म तो 0 हो गई, so a is equals to 5. So the partial fraction of this would be 5 upon x plus 2 plus 3 upon x minus 1. एक और करते हैं, वो भी हम कल यूज करेंगे. कल मैं अब डायरेक्टली क्वेश्चन में ये रिजल्ट यूज करूंगी. आई वोंट बी रीडूइंग दिस. Okay, another example that will come up tomorrow. It is break into partial fractions 2 minus x upon 1 plus x to 1 minus 2x. So again, since these are both linear functions, तो उसमें होता था a upon, I mean both the denominators are linear expression, so a और b आता था numerator में. Okay. Take LCM. The denominator then gets cancelled, तो मैं लिख नहीं रही, but दोनों साइड के denominator cancel हो जाते हैं LCM लेने के बाद. So अब x को पहले -1 सब्सटीट्यूट कर देते हैं ताकि b कैंसिल हो जाए. तो यहाँ पे आ गया 3 equals 3a, so a equals 1. Next, now I'm going to equate this to 0 ताकि a की टर्म 0 हो जाए. So 1 minus 2x इक्वल को अगर 0 करना हो तो 1 is equals to 2x आ गया और x is equals to half आ गया. तो अब हम सपोज करेंगे कि let x equals half. तो a की टर्म कैंसिल हो जाएगी. So we get 2 minus half, which is 3 upon 2 is equals to a की टर्म तो 0 बन गई, b की टर्म बन गई 3/2. So b equals 1 as well. So the partial fractions would be 1 upon 1 plus x plus b upon 1 minus 2x. Sorry, plus 1 over 1 minus 2. B is also 1. ओके, अब बस जल्दी से सारे केसेस देख लेते हैं पार्शियल फ्रैक्शन के। सो अगर न्यूमरेटर और डिनोमिनेटर में लीनियर होता है, सॉरी डिनोमिनेटर में लीनियर होता है, लाइक 3x upon 1 minus x and 1 plus 2x. Both are linear, so that would be a upon 1 minus x plus b upon 1 plus 2x. अगर एक repeated हो जाए, like 1 plus 2x whole square, so then we do a upon 1 minus x plus b upon 1 plus 2x and then plus c upon 1 plus 2x whole square. फिर होता था जब क्वाड्रेटिक हो डिनोमिनेटर में, लाइक 3x अपॉन एक्स स्क्वायर प्लस 1 एक है टर्म और एक लीनियर है, x square plus 1 and the other one is linear, let's say x minus 1. So you will have a upon x minus 1, and for the quadratic term x square plus b, ax square plus 1, you write bx plus. और अगर लेट्स से कोई क्वेश्चन हो जिसमें खाली क्वाड्रेटिक टर्म हो लेकिन रिपीट भी हो रही हो, so then it's going to be ax plus b upon x square plus 1 plus cx plus d upon x square plus 1 whole square. All right, that's all for today. कल के लिए पिछले सारे केसेस एक दफा दोबारा देख के आना. See you guys tomorrow. Allah Hafiz.